Okay, so this is a quick review on factoring complex trinomials, and we're going to do it in 3 different methods. You can choose the method you would like to do and follow along, but just make sure you know how to factor these, practice them, and review them frequently. This is something that you do need to know. So let's get a pen out here, and we'll start with method number 1. And method number 1 we're going to call decomposition. Okay, so let's say, for example, you've been asked to factor 6x squared plus 7x minus 3. So this is called a complex trinomial because of an a value that's greater than 1. So in order to factor a complex trinomial, the first thing that we do before we do anything else is we look for a common factor first. And often you won't find one, but if you do find one, it's going to make your life so much easier. So I take a look at all of my coefficients. I've got no common factor. So now I can go right into decomposition. When we factor using complex trinomials, what we want to do is we want to try and consider a number that's going to multiply to the product of the first and the last values in the trinomial. So we want to find a set of numbers that are going to multiply to 18 and at the same time add to 7. So we want a set of numbers that are going to multiply to negative 18 and at the same time add to positive 7. So we think about all the numbers that multiply to negative 18. That could be negative 18 and 1, negative 1 and 18. Neither of those are going to add to 7. It could be 9 and negative 2, or negative 2 and 9. And you can see that 9 and negative 2, if I add those together, that is going to add to 7. So these are the two numbers that I am going to consider. What I'm going to do next is I'm going to split the 7x into those two numbers that I just figured out. So the 6x squared is going to stay the same. And all I'm going to do is I'm going to split the 7x. Instead of writing it as 7x, I'm going to write it as the 9x minus the 2x. Because 9x minus 2x still gives us the 7x. And then the minus 3 still gets tacked on to the end. All right, now I'm going to consider the first two terms together and the last two terms together. And I'm looking for a common factor here. In the first two terms, you can see that 3 will divide into 6 and 9, as well as they each contain an x. So there's a common factor of x, leaving me with 2x for the first term, because 3x times 2x gives me 6x squared, and 3 for the second term. In the second set here, it looks like the common factor is going to be a minus 1. And I'd be left with 2x positive and plus 3. Now, if you've done decomposition correct, you're going to get two brackets that are the same, and that becomes your new common factor. So we're going to write our new common factor in front, 2x plus 3, and we're going to write the leftovers in another bracket, 3x minus 1. And that is a completely factored version of 6x squared plus 7x minus 3. Well, how do I know? Well, I can always check it, and let's check it in this color. And make sure you write check so that you're not just doing a big circular solution here. So if I was going to check this, now I have to expand out 2x plus 3 and 3x minus 1. And if I expand that out, I do FOIL. First is going to give me 6x squared. Outsides, it's going to give me negative 2x. Insides, is going to give me 9x, and last is going to give me negative 3. And you can see I'm back here at this step anyways, where I originally did my decomposition. And now I just simplify the middle terms, and I get 6x squared plus 7x minus 3. And because my check matches my original one, that makes me happy. All right, so that's decomposition. That is our first way that we can do this question. I'm going to give you a second way, and you can choose the ways that you prefer. So the second method we're going to choose is often called the Australian method. Sometimes it's referred to as the Popke method because it was a teacher who used to teach at the school. Oops, that's an S. Who brought it to Centennial. You're going to get to the same answer just by a different way. So same thing. If you've been asked to factor 6x squared plus 7x minus 3, what we think of in the Australian method is we think in terms of threes. So I'm going to start off just by setting it up, and I set it up by doing 2 brackets and a line, and almost like a happy face. And I'm going to take this first value and write it down 3 times. 6, 6, and 6. Then what we're going to do is we're going to split the x squared in between these 2 brackets. So that gets split there and that gets split there. Finally, I am going to see if I can find a set of numbers, same as decomposition, that multiplies to this product. So multiplies to negative 18 and at the same time adds to 7, the middle term. And again, just from the last time, we know that those are going to be the values 9 and negative 2. So I'm going to add one of those into the first bracket and one of them into the second. It doesn't matter which one. Then, in each one of the brackets, I'm going to look to see if there's a common factor. In the first one, there's a common factor of 3, and I'm left with 2x plus 3. And in the second one, there's a common factor of 2, and I'm left with 3x minus 1. There might not be a common factor in both brackets, and if there's not in one of them, you just leave it how it is. And I've got a 6 on the bottom. And what's going to happen every time is that the bottom value is going to end up getting canceled with what you pulled out of the brackets in the top. So 3 and 2 multiply together to give you 6. There's the 6 down there, and they ended up canceling each other. So what we end up with then is 2x plus 3 and 3x minus 1. Same answer, Australian method. Okay, finally, one last way that we can look at it, and that is by doing trial and error. Okay, so same thing. You're asked to factor 6x squared plus 7x minus 3. The way I like to set this up is I like to take a look at, I take the values of the first term and the values of the second term and write them in a little grid here. And then I write out all the things that would multiply to give me 6. So I could have 6 and 1, I could have 2 and 3, and that's all I got. And in the second, for negative 3, I could have negative 3 and 1, negative 1 and 3, and that's it. So what I want to do is I want to see which combination of values I can come up with that's going to give me this middle value. So I'm going to try this first. I'm going to go 6 times 1. 6 times 1 would give me 6. 1 times negative 3 would give me negative 3. And then I add those together, and 6 minus 3 gives me 3. So that combination's not going to work. I could go across. I could go with 6 times negative 3 and 1 times 1, and that would give me negative 9 plus 1. That would give me negative 8. So that set of combinations is not going to work. Okay, let's try this 2 and this 3. So 2 times negative 3 is going to give me negative 6. 3 times 1 is going to give me 1. And negative 6 and 1 does not give me the value that I'm looking for. Let's keep trying. If I did 3 times 3, that gives me 9. And 2 times negative 1 gives me negative 2. And 9 minus 2 does give me 7x. So I'm going to write in my two brackets. I'm going to choose my first two terms here, 2x and the 3x. Now be careful in this next step because the 2 needs to multiply the negative 1, so it can't be in the same bracket. So the negative 1 has to go in the opposite bracket, the positive 3 has to go in this bracket so that the 3 can multiply it. And again, I end up with the same factored values.